Alright, we're going to talk about R values in insulation. Insulation is a very important, crucial part of a building, of a structure, to keep energy efficiency going on. Okay? So insulation is what keeps your heat and your cold and hot air in or out. So if you live in California, it's very hot. The better insulation you have, the cooler your house stays. And if you live in Alaska like we do, the colder it gets, the better insulation you have, the warmer your house stays. So it's just all about heat transfer. If you have a good insulation, it ain't gonna do that. So there's only a maximum of different insulation that you can put into walls, ceilings, and so forth. So it's all based on the size of your studs. Okay, so on a wall you can have a R13 is the minimum. Okay, and the R means R value, so resistance value, and the number means the thickness of it. So the higher the number of the thickness, the better the insulation gets. So on a 2x4 wall, this is 2x4, right? You can do R13. They do now have an R15 for that same exact 2x4 wall. All it is a more condensed and more efficient. It is a little bit more spendier. So I don't know if you want to spend the extra money just for those two values. Some people do. If you live in Alaska, I recommend it. Then it goes to 2x6 walls. So you have a 2x6 wall, you can have R19 or R21. Those are the two. Okay, insulation comes in different types of insulation. You got batt and you got paper face and all that goes to spray foam. There's a lot of different ways you can get it. If you do a spray foam, you can get a lot higher into your walls because of the condensity of it. So there's a breakdown on condensity for different types of insulation, which we'll touch a little bit later. Right now, 2x6. So 2x8 or 2x10, you can put R30. Okay, this is usually mostly in if you don't have like in your attic, you can put you can put the batts in the attic, or your floor joists, you can put it in your floor. Okay, this is the recommended one. Unless you got a 2x6 floor joist or 2x6 ceiling, you can only put these two. It's kind of hard to fit this into a 2x4 wall because this is way more thicker than this. It's meant to go into a 2x8 or a 2x10. Okay, and like I said, it has two different types. There's faced and unfaced. When you're doing a wall, there's faced, there's paper, you can staple it to the wall. If there's unfaced, usually that mostly goes for attics and flooring. So that's kind of just a breakdown of the different R values for the different wall types. Now, you can get more R value in different areas by using different materials. Man, that's a battery. What'd you do with it? Okay, anyways. You can get different R values. So again, like I said, R is for resistance, right? And the higher the number, the better. Okay. Where's that little list? So like I said, there's different materials that usually are used for insulation. There is fiberglass batt, that's what I was talking about. There's fiberglass batt. Then there's spray foam. And then this is closed cell, open cell. There's two different ones. Then there's foam board, which usually gets put in a lot colder climates. Foam board. And then mineral wool, which is also called rock wool. And then there's cellulose, which is usually used as a spray. Cellulose, so it's a spray and it varies too. And then there's cotton, which is called denim. So for a fiberglass batt, for each 1 inch, you can get the R value. So for a fiberglass, it varies from R, this is per inch. So for per inch of insulation, you can get a R29.29 to a R38. That's what I was talking about, R13 and R15. The maximum you can get is the 3.8 R value for every single inch that you get. So if you do the math, right? So a 2x4 wall, you got 3.5 inches, correct? So if you take 2.9 and you multiply that by 3.5, what does that equal? Somebody can give me a
2, 4, 6, 19, 17, 8.7.
10.15.
10.15 to
Multiply?
3.8, yeah. 3.5 times 3.8.
13.3.
That's where you get your R13. Okay. You get it? I guess they don't do 3.5, they'll do it at 4. So if you do 4 times, 4 times 2.9, that's what you get. So that is for fiberglass. For spray foam, you can get, for the closed one, the closed cell is R6 to R7, right? For every inch you get 6. It's twice as good as fiberglass. For open cell, it drops down from R3 to R36, so 3.5 to 3.6. So it's not much of a big difference. Then the foam board, for every inch you get R36 to R4. With foam board, usually though, what happens is you put it on the outside as an additional insulation. So you don't put it inside the wall. It goes on side of the wall, and then you get another fiberglass inside the wall. So now you've doubled your wall thickness, right? Then the mineral wool is R3.2 to R3. What that cell is R3.2, 3.0 to 3.3. That's per inch. Cellulose is R3 to R3.8, and this one's R3.5. Okay, so for every inch you get a certain R value. So fiberglass, that's why they have the different R21, R19, and all the rest, right? When you get to an attic space, it's very recommended to not just put the bats, because the maximum you can get on a bat or a rolled out insulation is R30, right? And I think to some, like R38, I think is the maximum that it goes to for a bat or a roll or something that's together. So people, what they do is they take you have fiberglass as well, blow-in insulation fiberglass, or some people use cellulose. The difference between cellulose is this 3, and this one's 2.9, this one's 3.8 and 3.8. So it's about the same.
And we can use the spray foam?
You could use the spray foam, but it's not really commonly practiced and to do it. Like you have a lot of different kind of equipment that you need to actually spray it in. So it's the most common one you're gonna see is this fiberglass,
Temperatures
the
too.
cellulose.
If it's like freezing temperatures, you can't spray foam.
Yeah, so what the whole point of fiberglass is to keep the heat in or the heat out. So on like the attic space, if you live in a colder climate, you have your roof, right? And you have your walls. This gets insulation, this gets insulation. And then this right here, you can put insulation, or for every inch, you can put insulation like this, right? Inside. It is very, very important to not go to the eaves, right there at that corner, because if you close it up, this won't breathe, okay?
Oh, depends.
This won't breathe. And what will happen is this will start condensating, and this inside will start condensating, causing mold.
¿Por qué no se puede cerrar? Porque se condensa y la condensación como que queda mucha humedad. Necesita que respire, que entre aire.
Okay, so it's very, very important. Now, if you have a vaulted ceiling, you have to make sure that you insulate it correctly too, because you have breathing going on from both sides, right? If you put insulation, like you're gonna have to put rolled insulation on your rafters, right? Because most vaulted ceilings, they have the rafters and then they have like a collar tie right here. And what happens is people leave this open, because that's where a lot of you can't blow in insulation. You could put insulation in here between it, right? That's what people usually do, but the insulation will go in between the rafters inside here, right? This is all going to be insulation. So if you have a 2x6 rafter, right, you're going to use a R21 to R19, right? insulation on that rafter. But the most important thing is you have to put in something that will let air still breathe between the sheeting.
But if we have, for example, a ridge bend on the roof, we can do to the end or not, or it's still the same. For example, we have the ridge bend over here that can, they for the breeze, right? But I don't know if we can, we need to leave a little
You
bit.
can leave a ridge vent right here because the only thing it's gonna do is here. So if you're gonna draw it out a little better, more space. We gotta get some better cleaning supplies on this thing or something. Okay, so if you have, let's say this is your roof, right? And then you got your roof going like this. Inside, you got your collar tie, and you're saying put a roof ridge right here, right? The most important thing is when you have these rafters, right? The insulation goes in here. This is where the insulation will go, right? When you get to this part right here, right? Because these are the rafters, when you get to this part, it'll breathe into the ridge vent. You have to have a soffit vent right here.
Oh.
Right, you on a vaulted ceiling, it's almost useless to put the vents that go right on top of that roof because you're not gonna get anything out of it, right? So it's recommended to put a ridge vent on that, but it's also very important to put the proper, space between here. So what they have is these little plastic foam riblets that look like this. So if your rafter's right here, right, and this is your sheeting. That's your plywood, right? This will go in here as a breather, and then your insulation goes right here. You have to make sure that air can come through here, and it goes all the way up, and then it expands right here and goes out. The reason you have soffit to here is the pressure. This goes in and it goes out. Okay, if you don't do the insulation correctly and you don't use something like this, they sell them. It's like a plastic, some are plastic, some are foam. There's different types that you can use right here. If you don't do this and you still have a soffit vent where it doesn't do anything, the air gets stuck and the only thing you have is air coming in and out right here, which is very limited at that point, causing this to be damp and causing problems down the road.
I've seen people use like R19 on a 2x8, and then it doesn't expand as high, and so it leaves a top.
Right, but that's exactly right. You have to use a smaller one. I mean, I would still use a R19. I would just put, instead of like the foam one, I'd put something that's more stronger to keep that between the rafters going, So that's very important on a vaulted ceiling. Any questions?
Nope.
That's it.
OG Construction.